we are going to kind of go through this worksheet a little bit, and there'll be some work. Hola. Here you go, amiga. So, this week, so today we're going to kind of finish up with a part of this unit. Tomorrow we'll have a review, and then, excuse me, on Thursday there'll be a quiz on this stuff. So let me get to, oh, that's not the worksheet I want this worksheet. That one. All right. So this one I gave you, right? 3.4b. Does it look right? All right, it's on the main board too, but I'll write on this board. All right. So this talks about, they sure do have a lot of problems about water draining out of pools and stuff in this, huh? All right. So this talks about it says Allie and Dane work at a water park and must drain the water at the end of each month for the ride they supervise. Okay? Each uses a pump to remove the water from the small pool at the bottom of their ride. Graph each representation. Okay? So notice they have tick marks down here, but they don't have any numbers, so maybe we'll have to figure those out. It looks like Allie's pool is the red one, which is not red on your sheet because I didn't do it in color. I'm sorry. But Allie's is A at X for Allie's pool. And then the blue one is Dane's pool. So just kind of looking at it, whose pool do you think is going to drain the quickest? What do you think? So things you might look at, how steep a line is. So which line up on my board appears to be steeper, the red or the blue? The red? I agree. So you have I got a worksheet back there on that table for you. So there's these two different things. Now, so let's think about a couple things here. First off, does everyone understand? You have this person's pool and this person's pool. Each pool is draining. One person's is draining faster than the other. We're able to see that Allie's pool drains faster because she has a little bit steeper line. Okay. All right. So time in minutes and the amount of water in gallons. Water in gallons. All right. Let's see what we can do here. I'm going to lay this flat. So let's see what we can jot down about this information. It says, make as many observations as possible with the given graph. Okay. It says, Dane figured out that it takes 24 minutes to drain his pool. So Dane is the blue line, right? So this point right here is going to take 24 minutes because don't you think that this line would mean when it's all empty? And this pool is like the amount of water, so this is how much time. So let's think about this. It says it takes 24 minutes to drain the pool. Maybe let's do a blue one. 24 minutes to drain his pool. Okay, so I bet you if we go 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay. And yeah, my writing's a little sloppy, but these are all counting by twos. Each tick mark's 2 minutes. Does that kind of make sense? Okay. What is the key? So Dane figured it takes 24 minutes to drain his pool. So we got the 24 down here. So what is this feature? What is this line down here? X or Y? X. So do you feel that we're looking at Dwayne's pool, right? Dane's pool? Right there, this blue one. Takes 24 minutes. So what point is this going to be right when I get there? 24 comma what? Yeah, it's going to be 24 comma 0. Does that make sense? So what feature of a graph? Is it the x-intercept? Is it y-intercept? Is it slope? What do you think? That point. I have to sneeze. Oh, I feel so blessed. Thank you. So what do you think? Is that an x, y-intercept, or is it a... Oh, hello. What do you got here? I have this person. Thank you. So is it an x, y-intercept? Slope, what is that point? What is 24 kind of... What is it? X-intercept. Good. Do we feel comfortable with that so far? All right. Then it says, so I think we have number 2 figured out. It says Dane figured out it takes 24 minutes to drain his pool. Label this point on the graph. What is this key feature? It's the x-intercept. Okay, feel good about that. Okay, number 3 says Dane figured out the pump he uses drains water at a rate of 1,000 gallons per minute. So however his pump works, it takes 1,000 gallons every minute and it takes it out of the pool. Is that a lot? I don't know. 1,000 seems like a lot, right? So 1,000 gallons per 1 minute. Now, what does that kind of look like? Does that look like an x-intercept or a y-intercept or a slope or a... Yeah, I think it's a slope. I think this is a slope. Now, let me ask you this. Dane's is the blue line, right? D at x, right? What kind of slope is that? Is it a slope of 0, a slope of positive, or a slope of negative? What do you think? What kind of slope you got here? Negative. So we're going to make sure it's a negative out front. We have a negative slope because we're draining away, right? Says use 2 and 3, write an equation that represents Dane's pool. Okay. Write an equation. Let's see. I remember we had this as an equation. Do you remember that one? Didn't we use this once? Okay. Let's take a look what we got there. I just need a place to sit. All right, so let's start plugging stuff in. So I think I can say, maybe I'm going to call this x1. I'll call this y1. I'll call this one slope. So if we plug in things we know, y equals negative 1,000, x minus x1 we called 24, and y1 we called what? What's y1 up there? 0. So I think we could start breaking this down a little bit. See if you can catch what I did here. How did I go from this equation here to this equation here? What do you think I did? Yeah, I distributed a negative 1,000, right? Notice the negative 24 turned into a positive 24,000 because negative times negative is positive. I don't have a y sub 1. I mean, it's just 0. So basically, that's what takes place. All right. Friends, are you following what we're doing so far with this draining the pool activity? And it says calculate the y-intercept of D at x. That's Dwayne's pool. So what we do want to do is we want to figure out what this value is right here. That's the y-intercept, which is also called b, right? And we have to remember y equals mx plus b. That, like that, that's the y-intercept. So looking at that and looking at this equation right here, what's the y-intercept? What's the y-intercept of this equation? Noting this. 24,000. So our B value, which is the y-intercept, is 24,000. What does 24,000 mean in the context of this problem? Any ideas? What are we using in this problem? We're using time and we're using gallons of water, right? So is my time 24,000 minutes? Is my pool 24,000 gallons full? Yeah. 24,000 gallons. That's the total water in Dane's pool before he starts emptying it. Is 24,000 a lot of water? I think so. 24,000 gallons. Do you guys know? I grew up in Arizona, and we had a dug-in pool in our backyard, and our dug-in pool in our backyard was almost 40,000 gallons. It took a long time to fill that pool up with a garden hose. Basically, when you went to go fill the pool up when it was empty, you turn the water hose on high, go to sleep that night, wake up the next day, and it'd only be half full. You're like, oh my gosh. I kid you not, real story, real story. All right. Okay, so far, let's review real quick what we know. We have two different people. We have Allie and Dane. They work at a water park. They have two different pools that they are draining. We figured out that Dane, in 24 minutes, his pool is empty. Once he turns on the pump and the water starts going out, it takes 24 minutes or 24,000 gallons to go away. We found that the x-intercept is 24,0 for Dane, and that represents the x-intercept or across the x-axis. We figured out that he drains at 1,000 gallons per minute. We decided to make it negative because we have a negative slope to our line, because as I go to the right, it goes down. So we are losing 1,000 gallons per minute. I mean, that's a lot of water that's going out there. I hope you got a good place to put that water. And then we found the B value, the y-intercept, because we created Dane's equation as y equals negative 1,000x plus 24,000. So we found that the y-intercept, the B value of y equals mx plus b, where it crosses the x-axis, is 24,000. So before he started draining the pool, it was 24,000 gallons of water in that pool. Okay. I think I'm kind of sort of caught up on this problem. What do you think? So it says, what makes sense? What values of x make sense in this situation? Okay. So let me highlight or draw in a different color. You see these numbers down here? I just circled on the x-axis. Where did they start at? 0. Where did they end at? 24. So I'm going to start making us understand the square brackets. These are called hard brackets. Okay. These include endpoints. Now let me explain what that means here in a sec. Okay. According to the story problem, does Dane's pool, was it full at some point during this particular day of this activity? Yeah, with how many gallons? 24,000. Good. Okay. So Dane walks up to this pool and goes, wow, there's 24,000 gallons in this pool. I don't know how he knew that. Maybe someone told him. Maybe there's a little measuring device on the side. I don't know. But he said, okay, I'm going to start my watch and I'm going to turn the pump on at the same time. So it goes start, turns the pump on, water is just draining out, 1,000 gallons a minute, right? So from zero, so at a starting point at 0 minutes in, all the way to 24 minutes. At 24 minutes, there's no more water in this pool. It's gone. I mean, the sides might still be a little wet, but the volume of water is gone, right? Maybe it's like Arizona in the middle of July when it's 126 degrees outside. Things just dry up quickly there. All right, so this is called the domain. So we're using square brackets because we could have an endpoint. We have endpoints on both sides. We could start at 0 minutes, and after 24 minutes, the pump shuts off, the water's gone. Okay? And with the hard brackets mean we started and we ended. We can include the 0, we can include the 24. We don't like start right after 0. We start at 0 seconds. So maybe there's a timer on the pump. As soon as you turn the pump on, it starts counting, and the water's flowing away, and it's counting in minutes. I don't know. Okay? What is the output of this situation? So the output are the Y values, which we know as that is being the range. Okay? So let's kind of go back up here and take a look here. Okay, what is my y-intercept according to this problem? What's my y-intercept? What is it? 24,000? Okay, so I'm going to go for 24,000 gallons. Will I ever get to negative gallons? Like, how many gallons you got in the pool? Negative 675. I only have negative 675 gallons. Now, it's going to go down to what? 0. So I'm going to include 24,000 all the way down to 0 gallons. That's when it's empty, right? So that's our range. Our range is the amount of gallons. So this is the gallons. So it's going to go from bottom to top. So I go from 0 to 24,000. And this represents gallons of water. And the reason we go that way is range always goes from bottom to top. Domain always goes from left to right. Okay? Okay. We're done with Dane's pool. How do you feel? Feel okay? All right. So now we're going to switch over to Allie. Allie's pool. Let's pick more colors. I want to find some more colors. That's an okay color. All right, cool. Okay. All right. Allie's pool. Allie's pool. So we're going to go back up here. Allie's pool is the red one, right? So what can you tell me about Allie's pool? I'm going to erase right here. What can you tell me about Allie's pool according to this picture? It's more what? It's more full. It has more water. It's deeper. There's more. So what? I like this. So right here, the blue line is 24,000 gallons, right? And that red line's above that. So there's more than 24,000 gallons in the pool. Do you agree? Okay. But she has more water, but it drains quicker. She drains however much, 24,000 plus however this little extra bit is, and it drains quicker, so she's got a better pump. She got the fancy one. Okay. I have a question. This is kind of off topic. What do you think? The red and the blue lines, do they cross each other? What do you think it means when they cross each other? What do you think that might mean? Any idea? Say that one more time. I like this. Yeah, each pool had the same amount of water at a certain time as well. So this right here where they cross is a point. So at a certain time, they have the same amount of water in each pool where they cross. Oh. So like they could figure out their pumps, they could chunk their pumps off at various times after a certain amount of time, and they should have the same amount of water in both. Okay, so right now I know that Allie has more than 24,000 gallons. Because her y-intercept is bigger. Now, I don't know exactly how much she has. Like our graph, our chart wasn't perfect. Okay, so I can't go back up to it and see. I can see that it crosses the y-axis, the vertical line, but I can't see exactly where it crosses. I don't know. All right, use what you know about number 8 to write the equation that represents Allie's pool. State the domain and range. Okay, well, the range, I'm going to go from 0 gallons up to more than 24,000. Okay, do I know the exact value? I don't. What about the domain? Her domain, 0 to, what does it look like? Where does that red cross right there? It's cross at about 20. Cross at 20, you think? Okay. So her domain, these are going to be the minutes. Now, I don't know how I can make an equation for Allie's line because I don't know anything else. I don't know how much water she started with. I know that her slope is steeper, but not sure. I don't know the exact value. And I'm just saying that because sometimes they might give us a problem in life that we don't quite have all the information on, but we can kind of make some educated guesses on. Yeah. Okay. So let's just move on, see what happened. Ooh. Okay. Deep breath. Tell your neighbor we just answered this question earlier. Okay. So, where do you think A at X is equal to D at X? Sean, you raising your hand or are you just stretching? So right here. That's where the two are equal to each other. The crossing point. This is where the lines cross. So you can say the time when same gallons of water. Okay? And again, I don't know exactly what that point is. I just know it's somewhere in there. I think if we had more information, we could do it. But as of right now, I don't have enough information. But maybe we'll gain some more perspective as we go through. Let's see. All right. A at 5. So this was 0, 2, 4, 6, 8. So A at 5. And we're doing Allie's pool, right? We're going to come straight up. We're going to come straight over. And there was a tick mark there. I think this tick mark is 20,000, 40,000. So at A at 5, I think it is 20,000 gallons. So you notice I kind of came straight up and then straight over. Okay, so I think that's about 20,000. I don't know. Oh, wait a minute. Did we switch people's pool on number 12? says if d at x equals 2,000, what does x mean? This is Dane's pool. And I think our equation was y equals, we did it up here, negative 1,000 x plus 24,000. Okay? So you see this 2,000 here? This 2,000 is like here someplace. Okay? But I'm not sure. So let's see. This whole equation should be listed like this. D at x equals negative 1,000x plus 24,000. So I'm going to take 2,000 and replace d at x. Let's see if I can have room. 2,000. Uh-oh, I'm going to run out of space. Hang on. Maybe I can change this up a little bit. Ooh, it's kind of fancy. Nope, I can't do that. All right, so I'm going to take it over here. I'm going to say 2,000 equals negative 1,000 x plus 20. Oh, why is it going away? Because I chose the wrong pen. 2,000 equals negative 1,000 plus 24,000. How do I solve this now? How do I get x by itself? Yeah, subtract 24,000. Very good. That gives me negative 22,000 equals negative 1,000x. How do I get x by itself? Divide by each side by a negative 1,000. Negative over negative is what? Positive. Okay, so x equals, those cancel. So So 22 seconds into this adventure, or actually not seconds, minutes, right? It was in minutes. I'm sorry. Dumb stirrup. At 22 minutes, so what does this mean? At 22 minutes, there is 2,000 gallons left. Huh. So he drained quite a bit. Okay. And I think we can finish this last one. Let me just erase some of this stuff out. So let's try and figure this out. I'm going to change colors. Go green. Yeah. Can you let me finish this one? This is the very last smidge. Got it? All right. Ready? Where is a at x bigger? See that green region right there? That's where we had more water than the other pool. More water in one pool than the other pool. That's all I got for you guys today. So, hey, when's our quiz? On Wednesday. Use the restroom. Thanks for your patience. You guys both use one down the hallway. You can both go.